Okay, so recording is on. Khalid and Abid, I'm keeping you on the presentation mode. The second learning outcome is be able to design a relational database in line with a client's brief. Now, some grounds. A well-designed database is a prerequisite for a fast data retrieval and updates. If the database is not well designed, then obviously you will not be getting easy and faster data. Before you build the tables and other objects that will make up your system, it is important to take time to design it. A good design is the foundation to create a system that does what you want it and to do effectively, accurately, and efficiently. If you do not manage to design well, then obviously you will have a flaws in your database, like there will be some problems related with the normalization, and there could be much more problems. So some key concepts to keep in mind. Number one, to determine the purpose of your system. You should be able to very much clear that what is the purpose. To determine the tables you need in the system, you should be very much clear that you will have a kind of particular tables very much precisely defined. Determine the fields you need in tables. Identify tables with unique values. Determine the relationship between tables. To refine the design to add data and create data, create other system objects. So whatever you have to do, you need to have the things to be kept in front of you in advance. Now, what is an entity relationship diagram? An entity relationship diagram is a graphical representation of an information that shows the relationship between people. So it's not the case that you just start with writing the software, a database management system right away, and you may not know the actual requirements that we discussed in the first slide, but you come up with this information and represent this using the graphical form is called the entity relationship diagrams, and that shows the relationship between the people, objects, places, concepts, or events within that system. And ERD is a data modeling technique that can help define business processes and can be used as a foundation for a relational database. So three main components of an ERD are the entities, which are objects or concepts that can have data stored about them, the relationships between those entities, and the cardinality, which defines the relationship in terms of numbers. So for example, the R diagram represents the information system for a shop sales department. Might start with a graphical representation of entities such as sales representative, customer, customer address, customer order, product, and warehouse. So warehouse is an entity, product is an entity, order is an entity, sales representative is an entity, customer is an entity. Then the lines or other symbols can be used to represent the relationship between the entities, and the text can be used to label the relationships. So the lines, the sales representative is connected with the customer using a line, and the description is describing the relationship between the entities. A sales representative, one sales representative can have many customers. One customer can have one order or many orders. One product could be sold to different orders, and one warehouse could produce many products. So this kind of entity relationship diagrams represents the entities as well as the relationships among them to be represented. So in previous lecture, we discussed the cardinality, the associations between the entities, and here we are able to use that concept for representing the relationships into the diagrams, which is the term entity relationship diagram. So whenever you are dealing with a database, probably you will require to come up with the entity relationship diagram first, and then after representing or creating the entity relationship diagram, then you will be able to start or concentrate on the physical implementation. Certain symbols related with the planning of the entity relationship diagrams. Probably this rectangle is representing the entity, the double rectangle is weak entity, this diamond shows the relationship, the double diamond is the identifying relationship, association, the entity with attributes fields, entity without attribute fields, and there are many of the things like oval is the attribute and underline is the key attribute, like participations, like 1 to 1, 0 to 1, 1 to many, and recursive repetition. So all these are the symbols, and these symbols are not only used with the pen but softwares of the designing, like Microsoft Visio, Rational Rose, and many more softwares. You can use these symbols in order to create the ERD, entity relationship diagram, of your database before you implement this. Now we discuss the entity relationship diagram, the relationships between the entities, and now we are going to discuss the data flow diagrams. First, you know that which entity is related with other entity. After knowing this particular relationship, you should be able to know how the data flow will be carried out. A data flow diagram maps out the flow of information for any process or the system. It uses defined symbols like rectangles, circles, arrows, plus short text labels to show that the inputs, outputs, storage points, and the routes between each destination. Data flow charts can range from simple, even hand-drawn process overviews, in-depth, multi-level data flow diagrams that dig progressively deeper into how the data is handled. They can be used to analyze an existing system or model a new one. Like all the best diagrams and charts and data flow diagrams can often visually say things that would be hard to explain in words. They work for both technical and non-technical audience. For example, here is a data flow. User is making orders to the process order. The flow from user to the process order flow is going through the orders. The process order is providing the billing information to the invoices. The process order entity or part is giving the order information to the orders. Probably the invoices are providing the billing information to collect payment, and users are interacted with the collection payments. The collection payment and any particular user is provides the username and the address to the collection payment unit. So in this way, the shipping products is to be activated once the user gives the username and address, and fulfillment is done using the product by shipping the product to the user. So that is kind of data flow that really makes it clear. It's not necessary that you should write down the written description that which table will be doing and a particular action, or which data is being transferred to another, which table data is being transferred to another table for particular purpose, but the data flow diagrams can be represented to show the relationship between those uh, uh, flow of information. So this is kind of representation into the diagrams. You can use the same softwares which you used for the entity relationship diagrams. Particular symbols, give names given to these particular symbols, like external entity is a square, process is used in the circle, data store is a kind of square, but the edges on the right side are cut, data flow as an arrow. So the symbols, normally these are the external entities like a process, data store, data flow. So external entity, an outside system that sends or receive data communicating with the system being diagrammed. They are the sources and destinations of information entering or leaving the system. So any particular information is entering or leaving the system, you represent with the entity, external entity diagram. They might be an outside organization or a personal or computer system or business system. They are known as terminators, sources, and sinks or actors. They are typically drawn on the edges of a diagram. Process in a circle. Process, any process that changes the data, producing an output. It might perform computations or sort out based on logic, direct the data flow based on business rules. A short label is used to describe the process, such as submit payment. So you use the process, the data store, files or repositories that hold the information for later use, such as database tables or membership forms. Each data stores receive a simple label such as orders. Data flow, the route that data takes between the external entities, processes, and the data stores. It portrays the interface between the other components and shown with arrows, typically labeled with a short data name like billing details, like billing information. So we use the arrows, we use the entities, we use the data stores, we use the processes. So obviously, whenever you will be creating your own database, and then you need to focus on the symbols, data flow diagram symbols, and then you need to create your own entities and data flow diagrams, as well as the entity relationship diagrams. Now, what is data dictionary? It's a dictionary about the data that we store in the database. It contains all the information about the data objects. It is like storing all up-to-date information about the objects like tables, columns, indexes, constants, functions, etc. that you use for the data storage purpose. Why do we need all these information? It makes use easily identify, access, and understand the factors about the object. One can imagine the data dictionary as storing information about houses like house name, address, house, how many lives in the house, who is the eldest, youngest person, responsibilities of each member in the house, personal details of employee in the company. So in case of table, a data dictionary provides information about this name, security information like who's the owner of the table, when was it created, when it was last accessed, physical information like where is the data stored in this table, structure information like its attribute, names, its data types, constants, and indexes. So that's a very good example that if you want to store the information about a house, who's living, and how many rooms, how many people, what they do, is exactly you are basically housing a database. And housing a database, it means you are allocating the spaces to particular sort of information, and the sort of information really needs to be very much clear and predefined into kind of dictionary that's called the data dictionary. Below is the sample data dictionary view of the tables. Only few of the columns are shown below to get an idea of data dictionary. Since it is from user view, it will list only those tables which are created by current user, hence no owner column is displayed below. For example, table name is the student, lecturer, course, subject, table space, name, users. The student comes under the users, customer name is empty, cluster name is empty at the moment. The IoT name, the IoT, they are the locations of the particular field, like status valid, PCT free, PCT used. So this is a very much technical detail stored into the database about student lecturers, courses, and subjects. So all this comes from the table. When you store the information into a table, then a data dictionary is created against particular table. So the command used here is select asterisk from user tables. So user tables are the total number of user tables available in the database are student, lecturer, course, subject. Here is some technical information about the particular the tables. So that is the data dictionary. From the above example, it is clear that any data dictionary would contain the definitions of all database objects like tables, views, constants, indexes, clusters, synonyms, sequences, procedures, functions, packages, triggers. It stores the information about how much space is allocated for each object, how much space has been used by them, any default values that column can have are stored, database user names, schemas, access rights for the schemas on each of the objects, last update and last access information about the object, any other database information. So data dictionary is the key information about the structure of the database tables. You don't create basically this information, or you don't create this particular data dictionary, but when you create a table, then corresponding metadata, data about data is created and stored into the dictionary about the database tables. Certain advantages and disadvantages of the data dictionary. The advantages is that it gives the well structured and clear information about the database, because it is not necessary that you are only using the database as a human, but when you connect your database through the ODBC, the connectivity of a third party driver to be connected for the purposes to view your database to the external clients like a web browser, form, or anything else. So it has information, gives the information of structure about the database. One can analyze the requirement and any redundancy like duplicate columns, etc. So whatever the structure of the your database is, can be known very well, that how to analyze the particular, how to access that particular information. Is there any duplication of the columns or whatever it is, the information we call it as a metadata or data about data. You have the data in the tables, and the structure of the tables is called the metadata. So data dictionary is helpful for providing such information. It is very helpful for the administrators or any new database administrators to understand the database. Data dictionary helps the users by providing all the details in it. Certain disadvantages of the data dictionary: it should be well designed in advance to take all the advantages of it. If the data dictionary is not well defined, then obviously it will not be useful. The cost of data dictionary will be a bit high as it includes the initial build and hardware charges as well as the cost of the maintenance. Only for technical users, for example, if you wanted to focus on the database structure only for the usage purpose, and if you are only considering the usage, then if you really wanted to create the data dictionary, then it will not be helpful for you only unless you wanted to create this data dictionary for other users as well, so that they could also be get connected with the database by using the information provided in the data dictionary. So certain advantages as well as disadvantages have been discussed here. Decomposition term to be discussed here. The decomposition in database management system is nothing but another name for the normalization. Normal forms in a database are the concept of normalization makes a relationship or table free from insert, update, delete anomalies, and saves space by removing duplicate data. So, lossless decomposition example, sometimes the same set of data is reproduced, for example, name, price, category, and in order to reduce the prices of an item, for example, these prices, this table is not in the second normal form. You have splitted the prices and the categories separately. So categories like here DB is repeating over here. So you are trying to make and apply the first normal form, second normal form, and third normal form accordingly. So when you say that you want to decompose, it means you are applying the normalization rules that we discussed in the previous slide. So same way decomposition example, the examples following from the previous example, in order to best understand, you can go through the previous example and you can quickly get it. So only the thing is that the term decomposition is the normalizations that we did first, second form, second normalization, third normalization, and there are also further fourth normalization and some advanced normalization techniques that you really you need it when you are working with the very big databases, or when you become a very much professional, you have a responsibility to be a database administrator. Now, functional dependencies, the term in relational database theory, a functional dependency is a constant between two sets of attributes in relation from a database. In other words, functional dependency is a constant that describes the relationship between the attributes in a relationship. So for example, the public, if it is a book, then publisher ID, publisher name, publisher phone number, they have a functional dependency. Publisher ID has a dependency on publisher phone number. Publisher ID has a dependency on the publisher name. In other words, publisher ID is a main, and name and phone number, they have a functional dependency on the publisher ID. In the same way, the author phone number is dependent on the author ID. The author name is dependent on the author ID. So functional dependencies are termed as the one field is depending on the other field. A database table, a simple view, each real world individual of a class, for example, each customer who does a business with our enterprise is represented by a row of information in a database. Row is defined as a relational model as a tuple. So when you say a row in a database is called a tuple, a term, UVET, the cell phone number, the street, zip code is a tuple that is constructed over a given scheme. Mathematically, a tuple is a function that assigns a constant value from an attribute domain to each attribute of the scheme. Notice that because the scheme is a set of attributes, we could show them in any order without changing the meaning of data in a row. For example, if you wanted to show only the name, first name, and the zip code, then you can pick it up only particular values without affecting the structure of the database. The attribute names may be like a first name, last name, phone, and schema name is the customers. This is the information about the customer, which is represented in the terminology of the rows. Rows are called the tuples. This information is a kind of relational database. Indexes. You create an indexes in the database. A database is a data structure that improves the speeding of the data retrieval operations on the database tables at the cost of additional writes and storage space to maintain the index data structure. Some databases extend the power of indexing by letting developers create indexes on functions or expressions. So quick indexing is, as I gave you an example earlier, that when you read a book, you find a table of contents and index at the initial, and when you really wanted to access the particular chapter, then according to the index and the page number, you quickly go to that particular page and access the information. For example, a person ID1 is this particular person Larry Page. Page 2 is the Joshua Bloch. Third is the Brain George. So their particular information where they really work is number 1 is working in a company ID since this age. Number 2 is working in a company, this company. Number 3 is working in that particular company. So you really don't need to create or store the works in, but the company ID, if you wanted to repeat this information in a table, then you will be wasting the time and you will be spending time on every time search that okay, one is somewhere stored, one is, let's say, Google, and again another call came in for the second ID, it is again the Google. So instead of repeating this information, you are creating basically quick index of company ID into another company table. So indexing is quickly fetching the information of company name here, and the person is quickly being identified that what is ID of the person, what is the name, where is he working. So these are the internal indexes that are used in databases to create a quick accessibility of the data. Constants are the rule that database enforces to improve data integrity. You apply certain constants. Unique constants forces a column to contain only unique values. When creating or altering a table, you must define a unique constant. However, you can also create a unique constant automatically when you create a primary key. Referential constant is the means that you create a foreign key. As I discussed in the previous example, we created a primary key and a foreign key. So defining those foreign key and primary key comes under the constants. So referential key is the private when you define the foreign key. Unique constant is when you define that the particular column should not be used more than one time, it should be unique. Check constants, if you want to apply the particular check, for example, the number field should not be able to accept any name in the database, then you can apply the check constant. So here is a summary: not null, unique, primary key, foreign key, check, default. These are the constants. One of the most important topic of this lecture is SQL. SQL is the structured query language used to communicate with the database. According to the ANSI, American National Standard Institute, it is the standard language for relational database management systems. SQL is the language basically when you talk to the database using a particular command, and that particular command is used by different uh, interfaces of the database management system. You have a database, it is operated by the database management system, and the database management system understands the language of SQL, and using SQL you are able to provide the whatever the data or information is available in the database. You are serving the data to the end user. So SQL is most important. You need to start the SQL by using SQL W3C school. Here is the SQL. When you say, for example, there is a database, you are asking, saying, inquiring, select, asterisk, everything from the customers. Then you say, select asterisk from customer. A customer is a table like a customer ID, customer name, contact name, address, city, postal code, country. So you should have a database. You can use the SQL on your own database that is installed on your computer. For the practice purpose, you can go to W3 school. There is a live demonstration tables available over there. You can write over here like select asterisk from customers. You can write only, for example, customer ID from customers. Then you need to write exact customer ID from customers. So you got the customer ID only to be shown, to be presented, to be viewed to the front end. So how to design a query? There are some factors you need to consider. What the query will do: will it update, insert, delete, or retrieve? Knowing your data, how much data expected to handle, where the data is, expected outcomes. The forms, we have discussed that any data that is represented in a kind of window is called the forms, and forms look like is required to do the purpose of the form, and the representation of the database into the form, and the forms are used to create a database application which can run on the desktop. So you should be able to understand that how the forms are designed, how the forms will be communicated. Macros are certain internal functions. For example, if you define the particular calculations, for example, if you are interested to retrieve the total annual income, there is a table salary where you get a salary every month, but in a table you don't have a column of the annual salary, but you can define a macro or any purpose of the particular calculation within the database that has a formula which is defined using a macro. So database allows you to create a macro tools to automate tasks or add a functionality to your forms, reports, or whatever. Security is most important and refers to the collective measures used to protect and secure a database management system from illegitimate use and malicious threats, attacks. It's broad term. So security is also most important. Denormalization is a strategy used in previously normalized database to increase performance. So when you normalize the database, you basically create the additional tables to make it clear and make the relationships between the tables, to make it more accessible. But at some stage, you really need to denormalize. You really need to think about it that whether particular additionally created tables are helpful or not. So at some administrative level or at the superficial level of the database design, you also need to focus on the normalization. So overall, the second learning outcome is completed, but the relevant assignment with this learning outcome, which is tightly connected with the next learning outcome, is the SQL structured query language. You should be able to understand this from the basic commands to the advanced commands. And I have given you the idea. You should go to the W3 school and try to execute as well as understand all these commands and be prepared for your next session. So the session is over here, and hello.
Yes, sir, I can hear you.
Yeah. So do you want to ask anything? Any questions?
No, sir, no more questions.
Okay, Khalid. How about the Khalid?
Yes, sir.
Do you have any question? So I have given you the task to go through this website and come up with. Khalid, do you have any question?
Can you hear me, sir?
Yes, I can hear you. I can hear you,
No,
yeah. You don't have a question? Okay, I hope that you understood these two sessions very well. You can repeat these from the recording, and the assignment task is that you should carry on the practice with this tutorial. Yes, Khalid? I can hear you. Do you want to say something? Hi, Khalid. Do you want to say something? Okay. Maybe Khalid and Abid, if you have any questions, you can drop an email. I will respond to you. And I close the session here. And
okay,
see
sir.
you next Thursday for your another 2 sessions for the level 5. Okay?
Gonna be
Bye.
the same time.
Yeah, everything will be the same time. Same time, same day.
Yes, sir.
Okay.
Okay then. Okay, and you can send me an email if you have any questions anytime.
All right. All right.